Something ancient, fast, and unlike anything we've seen before is entering our solar system, and it's heading straight toward Mars. Officially named 3I/Atlas, this strange object is only the third confirmed interstellar visitor humanity has ever detected. But unlike anything we've expected, 3I/Atlas may offer answers to some of astronomy's most mind-bending questions, or raise even more. Scientists are watching in real time as this mysterious piece of the universe races past our neighboring planet. But what exactly is it? Where did it come from? And why are some people asking if it's even natural at all? You're about to find out. To understand what makes 3I/Atlas truly extraordinary, you need to understand what interstellar really means. Most space objects, planets, moons, comets, even rogue asteroids, are born somewhere inside our solar system. They're formed from the same cosmic debris that created the Sun, circling in long-established orbits that follow predictable patterns. But this is not that. 3I/Atlas is completely different. It came hurtling into our view from beyond the heliosphere, the invisible bubble surrounding our solar system shaped by the solar wind. That means this object isn't bound to our sun, or any sun at all. It's not looping around the galaxy like a loyal companion. It's a drifter, a true wanderer, flying freely through interstellar space for possibly billions of years before entering our part of the universe. The official name, 3I/Atlas, tells us two things. 3I means it's the third interstellar object ever spotted, and Atlas refers to the telescope system, the asteroid terrestrial impact last alert system that first picked it up. That name might sound dramatic, but it does exactly what it says. It keeps an eye out for threats from space. Only this time, the alert wasn't about danger. It was about mystery. Let's rewind to the discovery. The Atlas survey runs out of telescopes located in Hawaii, constantly scanning the skies for rogue asteroids that might intersect Earth's orbit. But back in 2023, astronomers picked up something different. Something that didn't follow the rules. At first glance, it resembled a long-period comet, icy rocks known to swing in from the outer edges of the solar system. But within days, tracking data revealed something puzzling. 3I/Atlas wasn't turning back around. It wasn't looping in an orbital path around the Sun. Instead, it was on a hyperbolic escape trajectory, a deep space highway that takes an object in and sends it straight out again, never to return. This kind of movement simply doesn't happen with solar system debris. Objects that are born here stay here. They might bounce, spiral, collide, or slingshot, but they don't just cut a straight line through our celestial neighborhood at breakneck speed. That's when astronomers knew it wasn't from here. Finding something like 3I/Atlas isn't just rare, it's cosmic jackpot rare. For most of human history, we had never, not once, spotted anything from outside the solar system entering ours. That changed in 2017 when an object now known as 1I/Oumuamua shocked the scientific world. It was narrow, reflective, elongated, and it accelerated without propulsion. To this day, scientists are still debating whether it was a comet, an alien probe, or something in between. Then came 2I/Borisov in 2019, which looked more like a traditional comet, icy, tail-forming, releasing gases. And now, here's the third, 3I/Atlas. But here's where it gets wild. More interstellar objects have been detected in the last 10 years than in the last 10,000. That's not because they suddenly began arriving. It's because we finally got good enough to see them. And that raises a huge, unsettling question. How many others have come and gone undetected? How much have we missed simply because we weren't looking or didn't know where to look? Now that we've spotted it, 3I/Atlas has everyone scrambling, not just because it's rare, but because of where it's going. This object is on course to pass dangerously close to Mars. Not dangerous in terms of collision. Scientists are confident it poses no threat, but dangerously close for scientific opportunity. In short, this could be our best ever chance to study an alien object up close. And we aren't ready. Space agencies, from NASA to the European Space Agency, are reprioritizing Mars-facing satellite missions to track the object as it makes its narrow pass. Scientists are working with every high-powered observatory on Earth and beyond, from Hawaii to Chile, from Hubble to Mars orbiters, hoping to capture even the faintest data signature. And even instruments on the Martian surface, like those aboard the Perseverance rover, are being evaluated for their potential to detect anomalies. And while a mission to intercept Atlas simply isn't feasible, we're talking years of prep and launch time. Talk is intensifying around developing systems for future interceptions. Could we eventually launch small, fast-response probes that attach, sample, or even ride along with these objects? If so, this moment, the Atlas flyby, may be the reason we start building them. Now let's talk theories, because you don't get an object from beyond the solar system flying straight through without attracting attention. Remember 1I/Oumuamua? It sparked immediate and heated debate. Its odd cigar-shaped, metallic-looking surface and unexplainable acceleration raised eyebrows among even the most respected scientists. Harvard professor Avi Loeb created waves when he published a theory suggesting Oumuamua might be a fragment of alien technology, possibly a defunct solar sail. While the scientific mainstream continues to lean on natural explanations, Loeb's theory wasn't dismissed as nonsense. In fact, it set off a firestorm of data requests and follow-up studies. Now here we are again. But 3I/Atlas isn't speeding up the way Oumuamua did. It's not reflecting light unusually, it's not rotating erratically, as far as we know, but it's still an object we cannot fully explain, from a place we can't trace, moving on a path we've never seen, which means the speculation is picking up steam. Is it natural? Just a loose, icy rock flung loose during a planetary system's chaotic early years? Or is it shattered material from a dead alien moon? Or, and here's where the online forums go wild, could it be something made, something designed to look natural, but masking a function we don't yet understand? These aren't just wild conspiracies. They're part of the reason interstellar objects have become one of the hottest topics in astroengineering and extraterrestrial life studies. Because if one day we do get proof, it probably arrives looking just like this: small, silent, and fast. But sadly, this is where the beauty of interstellar exploration hits a wall. Because even with all the excitement, 3I/Atlas is almost guaranteed to slip away, just like the others did. There are major reasons for that. First, size. These objects are usually small, smaller than traditional comets we're used to studying. Second, speed. 3I/Atlas is moving upwards of 90,000 kilometers per hour. That means we have an extremely tight window, just a few months, to collect data before it fades below detection range. And the third issue? Visibility. Interstellar objects often lack the kinds of surfaces or gas emissions that make comets spectacular. There's no glowing tail, no dramatic light show, just a faint dot moving extraordinarily fast. With our current tech, that makes deep study nearly impossible. Ground-based telescopes only get fleeting glimpses. Orbiters might get a few sensor readings, but after that, it's gone, back into the void, possibly gone forever. It's frustrating, maddening even, because with every passing object, we get just enough to be awestruck, but not enough to understand. Still, this isn't the end of the story. Far from it. Behind the scenes, space agencies are actively developing new tactics to deal with these kinds of discoveries. Concepts like space-based sky scanners that can detect interstellar objects sooner. Deep space intercept probes that sit and wait until something intrudes near the sun. AI-controlled drone explorers that can auto-launch from orbiting satellites within months, not years. Right now, these missions are just blueprints. But the urgency grows with every passing interstellar visitor. And many experts agree, it's only a matter of time before we either build technology fast enough to chase one, or one lands in our backyard. In the meantime, our job is clear. Watch, study, analyze, and prepare for what might come next. Because if another 3i shows up, or something stranger, what will we do? Will we be ready? Or will we just watch, once again, as a potential message from the stars disappear into the distance? So what are we really looking at with 3i/Atlas? Just a rock cast off by an alien solar system? A time capsule of ancient cosmic chemistry? A warning shot from a dead world? We may never know. But the fact that it exists at all, that we've seen it, tracked it, and studied it, changes something fundamental. It proves that the universe is not still. It proves that space is full of motion and mystery, and visitors. And whether by chance or design, one of them found us. In a quiet pass near Mars,